Hello, hello. So, I just wanted to record a quick update, basically how the state of the engine is right now. I'm not sure if somebody is ever going to see this. Probably not. I'm probably just going to record this for my own sake because I learned that it's kind of fun. Like, I've been working for years on this shit, and it's kind of fun to be able to go back through recordings or through old screenshots and see how you progressed. And I kind of want to do this more. I want to do more recordings and kind of have a history how progress is doing, because it's hella motivational to keep continue working on this crap. So what I'm going to talk about now, what I wanted to share now, is basically the sectoring system. So before, we primarily relate on pure GPU-based culling, or, well, beforehand we had a very primitive CPU-based culling system, which we then swapped out to a GPU-based culling system, which isn't very smart. It literally iterates all the objects in the scene and just determines its visible state on the GPU instead of the CPU, which is fast and which works fine with millions of objects, but just subdividing space into a quad tree or octree structure would probably be the smarter way to go. I decided for a little different system, not necessarily an octree or a quad tree. I just used the simple sectoring. Means the space, wait, let me quickly run it so you can see what I mean. Oh, wait, before I do that, come on, stop. Before I do that, let me quickly change this out from being a model object. Make some buildings, make some rocks right here. So from being the solar panel, which is actually a model and not a model object, to just being our rock number 4, which is the only rock model I right now have with multiple LOD levels, which allows it to be rendered many times. All right, so model object, rock 4, 50,000. We are in debug mode. Otherwise, we could go with more. But yeah, in debug, it's not that great. So let's start this up. I hope the game capture smart enough. No, it is not. Why is that? Why is that? Oh, there we go. There we go. Just took a little bit. Okay. So this is our scene. We can see there are a lot of trees. The trees are still culled over the GPU, while these little rocks down here, which you can see one there and a bunch of them like here, are now culled over the CPU. So the sectors, I hope it's visible. You can see these green lines. Basically, we have 256, 65, whatever sectors, which the room is divided in. The space of the map is still fixed at 64 by 64 kilometers. And this is then divided through these 265 sectors, which just makes 16 by 16 sectors. Right, so every object or every renderable or every static renderable, I should say, is assigned when it's constructed to this sector, and all of the meshes belonging to the actual object or to the model object, including all of the LOD states, so all the separate meshes for all the LOD states, is inserted into a data structure specific to the sector, and that allows us to quite easily cull them and quite super easily determine if they are visible or not. Because obviously every sector that is currently not visible can directly be culled away. There is no need to check the objects in a sector if the whole sector is not visible. And this works quite fine. The only frame problem we right now have, which you can see if you take a look at the frame rate right now, let's say I place a bunch of objects right there and I place a bunch of objects right here, and the line between the sectors is right here. So changing the sector, because this object I have attached to the cursor is a static object which just receives an update on each and every frame, which is fine if the update or the positional update is in the same sector. The problem arises when the new position is in a different sector. Which you can see if I move the cursor between those two sectors, the frame rate gets a small hit because that takes like, I don't know, 1 millisecond to rebuild the whole sector, which is not great, but it's what we got right now. So what do I wanted to talk about else? Oh, wait, let us stop here that the sun doesn't work or the sun doesn't travel further. Hey, I remembered, but somehow the mouse input is not working anymore. So let me quickly restart. All right, it's loading. Okay, so not the debug mode. Yeah, for sure. Like the external camera might be interesting. So, for example, there are a bunch of stones. Also, like these buildings I place are also run through the CPU system and not the GPU-based system. So if I press this to go into a different kind of camera system and press O, I go into the external camera mode where we can, or the out of body camera mode, which is why it's the hotkey O. We can have a look at how the scene looks like from a rendering point of view, but not from a culling point of view. Basically, it's an out of body cam. It's a stupid name, but whatever. So here we can now clearly see the sectors which are 100% not visible by the camera. Ignore the whole, wait, let me check if I can disable that. Yeah, the quad tree. So now you can clearly see that all the sectors which are not visible at any moment in time are marked red, which means they are not even checked for. You can obviously see that the terrain quad tree also just tries to show the patches which are visible to the camera, and you can see that the GPU culling system, because it's not based on the sectors, just perfectly cuts out the trees which are just beyond the camera. Which might also work, which might also be a little fun, is if we would move the camera itself or rotate the camera itself a little bit. That should technically work. Yeah, you can clearly see how the culling obviously removes the objects which are no longer in the viewport, and that works completely fine for both the CPU and GPU based culling, culled elements. So why have both? That might be a good question to address. Basically, the GPU culled objects to the algorithm I implemented. I hate calling things algorithm. Algorithm just means something complicated I'm too lazy to explain. Or at least I thought it was complicated. The GPU culling, for it to work right now, requires that all the textures or all the models that are culled over the GPU are stored in a texture array. And obviously in a texture array, the textures have to be of uniform size. Also, the GPU culling system doesn't support multiple materials for one single object. So every object can actually only have one mesh, which only has one material assigned. Otherwise, the GPU-based system will break, because also the LOD selection and everything happens on the GPU, and the way that the structures or the objects are built for the GPU just won't work if you would use a nice sunset right here. If it would be more complicated. It works very well for many of the same type of objects, so the trees are kind of a perfect use case for that. Trees, stones, and all kind of clutter that should be visible from afar. Obviously, when we have like low or close detail clutter like small stones, we would use some kind of particle system and not really have the object spawned in the scene. I need to wave here because my camera, my lighting goes out automatically. Damn, Philips Hue. The CPU-based system, on the other hand, allows a lot more complicated, or obviously we can just do more because it's easier to write. Every change in the GPU pipeline is kind of a pain in the ass, which is not I'm saying it's bad, it's just me saying I'm bad at it, and it takes quite a lot of time. Well, yeah, I think that's all I wanted to give an update on. I don't know if I'm going to do this in the future as well with a camera, because I can do this crazy switches with, how is it called? OBS Studio, so bear with me here. Probably I'm talking with myself, but hey, if you are one of the random persons that came across this video, thanks for watching.